It's a quiet, early morning, the perfect time for a hot brew of coffee. Making the coffee, you shake out the last few drops from the milk bottle. You give the bottle a good rinse and put it into a recycling bag. After you put your recycling on the curb, the local council comes by to pick it up. It would then get sorted and shipped to Thailand or Malaysia. But then what happens to the milk bottle? The plastic gets dumped in villages, left to pollute waterways and burn in open fires. Once we send our trash overseas, we don't know what happens next. We need to be accountable for our own waste. New Zealand ranked the second worst country for packaging recyclability. Clearly, there is something wrong with our recycling. And that became even clearer in 2018 when China stopped taking our plastics, leaving hundreds of tons of plastic with nowhere to go. So what can we do? What can we do with plastic that is just waiting to be recycled? How can we create a demand for these plastics within our own national market? With hydrothermal liquefaction, we can turn this plastic trash into treasure. Hydrothermal liquefaction, or HTL for short, is basically using really hot and high pressure water to melt plastic into crude oil. The HTL process uses water that's near the supercritical state. So we're talking water that's at least 300 Celsius and has the same pressure as being 2 kilometers deep below the ocean. The water takes on new properties, becoming very reactive. It's such an effective solvent that it can even break down the polymers in plastic. There are two reactions in the HCl process. In the first reaction, the heat energy causes the polymers to break down into smaller molecules. In the second reaction, hydrogen donation occurs from the water. This completes the smaller molecules to form the crude oil. We can think of HTL as just a cooking with a super hot and super high pressure pot. But HTL is just a cooking pot. There's a whole kitchen that needs to be built around it too. This is a simplified flowchart of what is essentially how we'll use HTL to turn trash into treasure. First, we'll collect recycled plastic waste from the public, and then we'll transport it to a sorting center where we can sort it and shred it down into smaller pellets. It's then processed in our HTL reactor plant, and then we need to separate our end products from each other to extract the crude oil that we want. But this crude oil isn't quite ready for use yet, so finally we upgrade it into a biofuel that can be used for energy production or plastic manufacturing. The amount of oil and valuable chemicals that we can extract from plastics is astonishing. But we have so many different types of plastics that react differently to the HTL process. Researchers are constantly looking for the most optimal conditions that yields the most oils for the plastics. For many plastics, researchers were able to achieve very high yields of 80 to 90% and even able to completely liquefy some of them to oil. However, some plastics like PET have much lower yields of oil with just 16%. The point being is that HTL has limitations to which plastics can be processed, but researchers rapidly discovering how to optimize oil yields. The biggest advantage with using HTL is how robust it is. Researchers at the Pennsylvania State University used an HTL reactor to process mixed waste products that you would see from the public. The mix of waste included a biomass component and plastic component that represents common packaging plastics. Surprisingly, they found that mixing the plastic and the biomass together had a synergistic effect, increasing the total yield of oil. With HTL, we could easily recycle any plastic, contaminated, wet, multi-layered, plastics of all types. The environmental benefits. Compared to other recycling methods, it has the least environmental impact. Because HTL is performed in a high-pressure reactor, it uses a lot of electricity. But luckily, we live in New Zealand, where 90% of our electricity is renewable. The biofuel that we're able to produce with HTL here will have much lower carbon emissions compared to other countries. And as a bonus, the biofuel created from HTL will have a net reduction in New Zealand's greenhouse gas emissions. This is because biofuels, as a substitute to fossil fuels, produces much less greenhouse gas emissions. And with our goal to have zero greenhouse gas emissions by 2050, every little bit in reduction helps. In a recycling survey, Wellingtonians knew what could and couldn't be recycled correctly only 2 out of 3 times. Plastics recycling is confusing. And this is where HTL presents a huge social benefit. With HTL being so robust and able to process all plastics of all types, it would take the confusions out of plastic recycling and would hopefully destigmatize New Zealand's plastic recycling industry and inspire Kiwis to recycle more. The commercialization of HTL is still in the early stages. Only pilot plants are being used for testing HTL to process wood and forestry byproducts. It's only right now that the recycling industry is just starting to move. The first ever HTL plastics recycling plant will be opening in the UK next year. It'll be able to process 20,000 tonnes of plastic waste per year. It was designed by an Australian company, Licella. There are many companies that use HTL to produce biofuel, but Licella is the most notable as they're the leaders in the industry of using HTL for plastic recycling. They've been backed by the Aussie government with more than $100 million of funding and 13 years of research. Licella have only patented the specific processes used in their plant, so the HTL process itself is still up for grabs. If we're to set up our own HTL plant in New Zealand, the plant should be next to a recycling centre because a major cost factor would be the transportation of plastics. There'll be no shortage of supply to feed the plant because we export so much waste overseas. About 90% of it, plastic waste overseas, 90% is exported. In 2018, we exported 35,000 tonnes of our plastic waste. Licella's plant would have been able to process 20,000 tonnes of plastic waste per year. So if we invested in a same plant of similar scale, we'd be able to cut down our plastic waste exports by more than half the cost. If we were to invest in an HTL plant in New Zealand that is able to process 20,000 tonnes of plastic waste per year, it would take an investment of 154 million New Zealand dollars. But we'll be taking the plastics recycling work that we were sending offshore and bringing it back to New Zealand to create more jobs. Despite these astronomical investment prices, there is a profit to be made. But this profit greatly depends on the price of oil, which is a volatile market. This graph shows how the fuel price changes based on the carbon emission price. The carbon price is the government tax for carbon emissions. The yellow line represents the current price for our fossil fuels, and the black line shows the price that the biofuel needs to sell at to break even, when revenue equals total costs. As this carbon price increases, biofuels become much more appealing than fossil fuels. The current carbon price is $61.50 New Zealand dollars per tonne. Now, the fossil fuel price has overtaken biofuels, meaning that we could produce biofuels for $1.21 of NZD per gasoline litre equivalent, and then sell it at a higher price to match the fossil fuel price of $1.29. So this gap here between the fossil fuel and biofuels represents the profit that could be made. We're already in an economy where fossil fuels is becoming more expensive and it's becoming more profitable to have biofuels to start to enter the market. We want to transition to a circular economy, but we can even go a step further, a donut economy. Reimagined by Tiana Balsadine from a Māori Tūhoe perspective, this multi-economic model places the environment at the center and social elements around the perimeter. Environmental issues should be at the heart of our economy. When we start to draw focus to these issues at the center, the power spirals to the center and rebounds outward to give a regenerative effect to the economy and benefits to our social well-being. This donut is also called takarangi, which means spiral. It's a Māori motif that expresses how our efforts to benefit the environment will flow over to positively affect all other aspects of our life. HTL is a solution that fits the goal of the donut economy. It's a solution that doesn't just aim to provide a circular balance, but could potentially benefit the environment and provide a regenerative effect. And once we lower our contribution to plastic pollution through HTL, we will see benefits of a sustainable source of oil. And the donut model shows that we'll see energy benefits through clean energy and more income and work, which will benefit all other parts of our social well-being. We should be responsible of our own waste. Our waste contributes to carbon emissions, climate change, plastic pollution, and all of that has global impacts. We can all become kaitiaki of the world. With some really hot and high pressure water, we can turn our trash into treasure. Thank you.